sorts of cans.
I'm surprised just which can.
Oh, thanks. Yeah, well, I did the same thing. I had like 4 little chocolate bars in there. Like 5 snacks.
Is that lunch?
Yeah, pretty much. Oh, cool. Oh my god.
Yes. All guesses. Oh, also, I have somebody interested in getting on the math club listed.
Oh,
Can
okay.
you add them?
Yes.
Okay, I'll send you an email with their email.
Cool. Sounds good. Okay. Oh, that's good.
How's everything looking on the far side?
Yep.
Oh, good.
Hey, thanks. For sure have an Airbnb room. We were accepted in Los Angeles.
Yeah, probably abstract tonight. Well, yeah, because I don't think I have anything other than that optics homework due tomorrow. You know, I just finished that up, so it's double check that like half wave plate is an appropriate term for a wave plate that alters the wavelength by by pi.
What's the definition of a wave?
A wave plate, so like polarizing it, basically there's like a fast axis and a slow axis, so it'll like change.
Yeah, but does it by definition apply at full?
No, not necessarily.
So probably not.
There's something like it might be like half wavelength wave plate or something. I don't know, that seems kind of redundant to me. But like a half wave plate seems a little weird too. It's like I just need to make sure I'm using the right terminology.
Yeah, I don't think he'll care, but
Yeah,
you could probably just ask him on your homework to be like, is this the correct term?
Well, I just need to look at the book, which I don't have on me. Yeah.
I just
I'm not a huge fan of it either. But what do you do? Seriously?
I need some special attention today.
Yeah.
Good. Good. It's pretty short. 1,300 characters, including spaces. So
Holy shit. Yeah. How do you do an abstract for a poster?
what do you mean?
Like, how would I phrase the abstract when I'm submitting to present a poster? This poster will be.
No. Don't mention that it's a poster.
Yeah.
I think the abstracts would be the same regardless of doing a poster or a talk. You're just kind of abstracting your project, not your presentation.
But I need to keep it super vague so that no matter how much progress I make, I can still present something.
Well, it's at the bar high, you know?
Hmm?
It's at the bar high. Be very small.
Yeah, Wagner told that one of his to submit this as abstract. Like, so, you know, like basically saying that, like, the Lance Boltzmann theory and its applications. And like, that's it. So you can just do whatever you want.
That's fair. But then you run the risk of not being chosen as a talk if they need to push somebody out.
I don't want to do time.
Why? But I mean, if somebody was as vague as that, and they were not trying to get into a talk,
Yeah.
they'd push you out
Right.
in place of somebody else who has a more specific goal.
Yeah, no, but I
But yeah,
just do a poster and like,
as a
this is
poster.
where I'm at. And, yeah.
I still need to compose my APS abstract.
So what you should do, like enjoy the vibrant equipment, but the little goal that we will go over, and I will try to do it and share with you when I'm ready, is to implement the transmission overview. So just take a working version of code for barrier or the finite box and just integrate over half space, accumulate it as a variable, and then show it as function of time. So before it passes through it is 0, and then after it goes from one region to another and starts growing. So I'm trying to find a working version of the code so that I do not correct same errors again and again. But you are invited to try this little exercise if you have Steam. Do you have a working version of the code?
How do you define working?
A working that doesn't give you errors from the first run.
I think so.
Can you share?
Okay, let me just double check my statement. Do you want me to email it to you?
Yes. Well,
Which
doesn't matter which one.
which code are we using?
Yeah, do you want the wave packet free AVP?
Or do you want the one with the barrier on it? Or
The last one.
WP free AVP barrier?
Mine
Yes,
has a barrier.
yes.
I guess it's fine.
Bless you, bless you, bless you.
Also, which email do you prefer? The Gmail or the NDSU?
Anything except NDSU.
Noted.
That's a harmful sound cylinder right there. That doesn't work so well.
You just make me real upset today, you know that?
Thank you.
Also, for the final project in this class, the projects will be given as presentations during our final time, like the 2-hour block of finals. Is that correct?
I'm yet learning about the customs at the school. I hate finals, and I hate the word and everything that is connected to it. So if you can do it last week before finals, if there are no administrative bans on this, would be better.
Alright. I'm just looking for like a deadline, so the week before finals week is roughly when it should be done?
I'm going to surprise you guys. The presentation will be the easiest part, and it is not very important when you do it. In addition to presentation, we will do written reports about a week before the presentation, and it is, I don't know, for some of you who are congenial writers, it is much easier than to present, but for me, like, I can present for 6 hours and be tired of writing one paragraph. And it could be logical to make presentation and then prepare the preparation, but when you present, you get a boost of adrenaline and you want to get a feeling that everything is done. Otherwise it is like coming up and down, too much stress for... Yes, this is the right version, thank you.
Oh, one more project. Would you like us to meet with you here sometime soon to choose our project?
What do you mean, meet soon?
Sit down in your office and discuss possible projects?
I will be happy to do it if you want to, but I think we can make it much easier without this investment. I'm having a very small computer.
Yeah.
Yeah, mine worked a lot faster.
Maybe this recordings delayed substantially.
Oh, that could be.
And they test new, I don't know if it is
Way
like
further back.
truly new technology, but they placed camera there.
Interesting.
Okay, then we have something to start from. And if it is only very selected part of the class, you can go without rush, and the plans for today are not super ambitious, so we will go slowly but surely. So for choice of the individual research project, I suggest we we practice democracy again. So you start thinking about it. I will offer a dozen of possible subjects. Probably you will have this list with you for a couple of days, and then one day we all just fill the list you either check one of the pre-made subjects or you just select the one you want. But if you want to meet, I would be more than happy. It will help to bring it to much higher orbit. But we can survive without it. Is the font visible enough, or I should practice?
I can see it from here, I guess.
Well, the question is primarily to Mark.
Yeah, I can see it.
You can see it?
Really?
That's impressive. I barely see it from here. Maybe I'll increase it just a little bit.
Is that just like copy pasted from your poster? Like,
So this is the abstract for the poster. The
Yeah.
poster one was really short.
okay.
Too short.
Okay, so we are not going to play with the setting up the potential. We probably can postpone it to the time when you'll have record attendance to the other limit. But let's develop the just little piece of code. It will be a couple of lines that will accumulate this transmission probability. So the idea is super simple. It is same. We kind of discussed it last time. Integrating from 0 to cell over 2 with the probability distribution, and calling it maybe probability at left, and then doing the same probability right of time from half cell to full cell with distribution Tx, dx. And we will practice accumulation of the, maybe you can call it average, or you can be creative, PL, APL, PL. So PL here doesn't stand for photoluminescence. It's for probability at the left. And if you accumulate it this way, then the block of data will grow, and after this loop is over, you can plot it. Right? Make sense? Or not?
What system are we looking at? You're like, what,
Doesn't matter.
what context are we?
Oh, okay. Should I bring more context? Sure. Okay, thank you. Well, it's so amazing to play with it.
Uh-oh.
Focal length is pretty screwed up.
It's the Sasquatch.
Oh, okay.
It's cool how it can optimize that.
Alright.
It's pretty interesting.
Well, what's that crap?
So we fuck. That's cool. So we do have some potential inside our simulation cell from 0 to L. And instead of L, we should have a variable like x maximal. So there are periodic replicas before and after. And type of potential doesn't matter. We can, for example, we can start with a barrier, but it will be universal and applicable to much broader range of potentials. So if we prepare the initial wave packet on the left half.
Oh, I see. We're talking about transmission and
Transmission,
reflection.
yes.
Oh.
Then after some time, it may appear on the right part, right side of the cell. So you have already computed all challenging parts, the quantum dynamics, how wave packet passes through the barrier and either reflects or passes 100% or splits on two parts. But this is more qualitative. If we believe, or if we want to believe that it helps quantitative analysis, if one can get anything useful, if one can interpret true experiment with these simple models, then we may want to improve the potential and improve the way we analyze outcome of the simulation. The expectation values, the observables that we did set up by now will not work because, for example, we do have expectation value of position, but if you have splitting of wave packet on two pieces, then it will be neither left nor right. Expectation value will stay in the middle. We can interpret that if it is in the middle, it is 50% transmission, but it is kind of too much of hand-wavy philosophy when it is not needed. If you need just yield of reaction, proportion, probability that it did happen, we can directly compute it. Is it enough for context? Okay. And we need nothing more than this integration. You probably can do it 4 times quicker than I. Most interesting and pleasant part of the game.
A little bit.
Thank you for encouragement. Almost.
Oh, too much.
Too much? Use what?
Oh, Easy Rod. Have you ever seen Super Troopers?
Oh.
Okay. It's from that movie.
So I'm going to look into the part of the code inside the loop. So, and as soon as we define this probability 2 and 3, in fact one can do real potentials with method 1, with momentum space, but then one needs to convert potential into momentum space, which is kind of very counterintuitive.
Yeah.
Well, Coulombic potential 1 over r should look like 1 over momentum squared. So for some functions it is possible, but it's too much of counterintuitive things.
The quantum is counterintuitive.
Yes, but everything should have limits. So probability left 2, probability right 2, probability left 3, probability right 3. Line 140. So I am looking for an opportunity to make it more elegantly. Okay, number of points. So I'm going to replace summation by integration as we always do, and I need limits. What? No.
So how does that definition work there?
Huh?
The part that looks like a commutator? Where you've got like XX, XXX in the brackets? It's like how does MATLAB actually interpret
Yes,
that?
I
guess?
understand the question, and it just takes me a couple of flops to convert it into human speech. Let's do it explicitly. Oh, I don't need to do it so advanced. It could. I'm thinking too much. Round of endpoints. Copy. Paste. Very good. So we approximately set up the midpoint. We just do not want it to be non-integer.
Yeah.
And about your question here. So if it would be a square matrix, it would be like 25. Wait, let's just try size hop, which is X operator rather than heap hop. Okay.
But what does, so you have, so when you have size.
Rows and columns, number of rows, number of columns.
But it looks like you're defining two things with just like size X, basically, is like how I'm reading that, I guess.
the operation size returns two numbers.
Ooh. Is XX and XXX two new variables that are defined
Yes.
right there?
Yes.
Okay.
That might be the answer to our question.
Yeah.
Typically, well, simplest thing is single function of single variable.
Yeah.
And here is like two functions of one variable. We need just space where to funnel them.
Okay.
Okay, so we have the midpoint, which will be this n2. And now going back to the inside the loop. Which something.
Can we just use x2 for that? Isn't that how that's defined?
Well, x is to some sort semi-continuous, semi-discrete. It can take fractional values.
Oh.
And if
okay.
you do summation, it's better to have the integer counter. So you can do here sum prob 2 from 1 to, what was the variable? n2?
N2.
Yeah.
Okay. Let's check if it. If it agrees with this and doesn't generate. Okay. And now we can do for the second half. From n2 to endpoints. No errors, and the numerical values look like they would add up to 1. Right? So together, left plus right probability should give the total probability. So we are on a right track. So we do have 4 new variables, but they are computed instantaneously, just once inside the loop. And we may want to accumulate them into trajectory, into set of data at each point of time. So let's just find. Who makes me to stand? I can do it while sitting. It's much easier. And now I'm going to repeat it 4 times, so it is probability, left probability, right? Second and third, second and third.
That should be a semicolon inside the brackets there.
Yes, I'm just blindly following the pattern before.
Oh,
It's shorthand for, I think it's vertical.
Yep.
So instead of hitting enter to go into the next row, you just put a semicolon.
oh,
Because if there was nothing, it would be.
yeah.
3.
These things aren't fine. 22.
R3.
Most creative.
R3.
I think it's a pending value each time.
Save. Well, it will not work if I run it right now. It will generate an error. You can try it, but I'm confident. Why? Because these variables haven't been declared yet. So I may copy them, or maybe at least one of them, to remember this combination of 4 symbols. And before the loop is started, you see there is a, although MATLAB is not as rigorous as other computation programming languages, in this case it is much healthier to have a declaration. Not much healthier, it will just not work without it. So, initialize transmission trajectories. So we can run. What's the language? I'm going to delete this stuff, as otherwise it will garbage everything. Okay, and now we can open new figure and try to plot whatever our little programming effort. No. Okay. Good. A, B, R. Okay. So here you do have a good tool for research projects. It is something that will be helpful. So the red and blue lines stand for transmission and reflection probabilities. Since you do have, you see that there is some garbage if you propagate it long enough. So we probably shouldn't look on the right edge of the figure, But here we do see that originally we have 100% that wave packet is on the left, 0% that it is on the right, and after some transition period, about 25% has transmitted, while the rest has reflected. Right? So we can consider it twofold. First, as a boring exercise of basics of quantum theory, but we can be much more ambitious. If we design a potential that describes realistic problem and we do not have restrictions, there is a procedure that I will share with time and before semester to pull potentials out of ab initio calculations. We have one-dimensional potential that is based on high-level like DFT or TDFT calculations. And then we can go very far in predicting either charge transfer or reaction description for realistic systems under approximations that we can squeeze it, project it onto one-dimensional problem. If you know what is our favorite one dimension, like reaction coordinate, or if you know that it is a planar system where only the z direction plays a role and x and y are symmetric, then it will be powerful and useful too. So let's, I'm going to polish it a little bit, maybe include the line at the end of the code that this window will pop up, make lines thicker with labels so that we can use it universally for any other potential, and then we can either depart immediately or change potentials or look onto other things that are on our radar, which are variety of potentials, including true solids, and harmonic potential with right choice of mass, which looks primitive, but one needs to do it with sober head and clean heads and hot heart. If in a rush, one can make mistakes. And I'm just playing open cards, what is on the radar. There will be, maybe not next week, in 2 weeks from now, the so-called Marcus theory, when one introduces, now I'm going to surprise you, when one introduces more than one potential coexisting simultaneously. So if you were exposed to some computational chemistry before, it shouldn't surprise you. It's like potential energy surfaces for ground and excited state, or for several excited states that may cross. Right? And if you were not exposed to it, the simplest explanation is that if we do have a system, a molecule or group of molecules like reactants in different electronic states, for example, one is when two reactants, A and B, are neutral, and another state when charge has transferred from one to another, the interatomic distances, the potentials, will look differently, because upon charge transfer, even if you do not know the structure, if those are spherical horses in a vacuum, they will start experiencing Coulomb attraction in addition to their additional forces that make them stay near the equilibrium, and they will change the steepness of potential, equilibrium position, and many other things. So it will be most complicated thing in the course, although not most complicated thing in the life. We will not get to there today. But let me fix a bit of code and share it with you as a minimum. And maybe if you have Steam, we can make a little more progress further. No? Yes.
Vomit on the page. Different sentences.
You're missing an apostrophe on that one.
I do. Let's count.
Oh, now you're missing the apostrophe on line width.
This is computation.
Right.
This is where the time goes.
Wow, look at that.
So beautiful.
Nice and symmetric. I suppose as it should be. Be problematic if it wasn't.
And now we can go to the
Well, the probability.
Yeah, what is 2 and 3?
The different methods.
Oh,
Yeah.
yeah.
I see there are some pre-made things for this. Reflection part. Okay, it was already here, but we reprogrammed it maybe more elegantly. I hope so. And by the way, do you see here the energy? So later we may use it. There is no much scientific value, but it will make things much more comprehensive for general audience if you offset your wave packet from 0 by its energy, and then you will see whether it overcomes the barrier or not in plotting. Right? Oh, it's something that we can do without too much stress to our schedules after we are done with these probabilities. So figure. No, it's not really.
Yeah, no. Crazy. Right. Yeah, that's much gotta get my chemistry done tonight. What one? I got a grade. 200 tests tomorrow. Yeah, it's doing fine. No. It's online somewhere.
So number of times steps
It's
is
on
n cal.
Oh, you can look at the lecture. It should be on.
What's number one?
Okay, so we can stop here or improve it further. There is an operation that I do not know how to do in command line. It goes only in mouse operation. How to set up background color. Okay, so with this tool, and I should send email to everyone with this part. With this tool, we may start with ambitious words, an exploration of structure to activity relation, quantitative structure to activity relation, QSAR, which is a keyword of popular area of research. I'm a bit exaggerating, but we can model any structure by potential, right? And activity is ability of a structure to allow reaction to happen or electron to transfer, right? Then we can either measure quantitatively that percent it has been transferred after certain time, or if it is a really slow process, you can see that these slopes can be very different, and this transition period can go for forever. So you can also find a slope in this transition period. And those are pieces of data that are very valuable, and it is something where this approach can complement experimental research, and some of the results obtained by such relatively simple calculation can be publishable. So you can find something that is of interest to the community. Okay. Program minimum, send this piece of code to everyone. And then we'll discuss our plans, if any.
Gyration tensors.
Sorry.
I think that's journal. Should go myself. So I'm talking about eigenvalues of the gyration tensor.
I mean, it has to be a tensor that describes like the rotation. So that similar like a tensor.
I mean, it's talking about a spherical particle. So what would the indices of the tensor be? There's three eigenvectors. It's got like a 3x3 matrix. Yeah. So, if I squish the sphere, it becomes a very elongated ellipse of the squish two sides.
That's like the gyration.
What do you want to do?
It's like how Presley's hits.
Okay, let me check if you have something similar by your own effort, or if not, you can do these things yourself by running the code that has been distributed. Yeah, yes.
Function undefined. It's an undefined model.
I didn't use that.
Why do we give each other the sheet? How did we even start? Oh, I can't end this. I'm just going to see what's happening.
Escalator.
check if I have set the right.
I think this is an older version. I want to rewrite this code in Python or something.
Just to put.
So I understand it. So I can't parse this. It's too much.
Did you get it running?
Still waiting for the newest.
I have sent it.
Yeah. I just haven't gotten it.
This is the old code that I downloaded before. This is a harmonic oscillator.
Mhm.
So it makes sense.
Okay.
That's cool.
So what do you mean waiting for transmission?
Yep. From the email server. I don't know. It's just not connecting.
You have the. You can unplug the Ethernet from web computer and plug it into.
It sounds like work.
Huh?
That sounds like a lot of work.
No, it's natural.
What if I screw up the computer?
You'll not tell
And
anyone.
I mean, it worked like 30 seconds ago. I'll catch up. I just had to
Ooh, that one
reopen
right
the
there.
application. We're good.
Yeah.
So, I think it would be realistic if you do just little non-scientific thing, a little further polishing of the code that would offset the wave packet according to the energy. Then it would be more intuitive to analyze. Do you feel excited about it or bored about it?
Real excited.
Really excited.
Really excited.
Okay.
So when you say that they like to offset it by the energy, are you just, it's like, you're talking strictly graphically offset?
Yes,
Okay.
strictly graphically. It will not change anything in the true observables.
Okay, yeah, because I was going to say that would completely mess everything up if we actually like moved it. So it wouldn't be normalized anymore. God damn it.
I can't have anything like that happen.
In fact, it would be infinitely normalized.
Infinitely not.
That's right. It would be a divergent integral. You tried to figure that shit out.
Yeah, but then you know how to normalize it. You just divide by infinity.
Yeah, there you go. Look at all this. Look at all that.
Forget about what calls it. It's a fun little shindig.
Right. Just take the derivative of it and
Yeah,
eventually
honestly,
it'll work out.
I don't really understand why that works.
I think I proved it in real analysis at one point. It's not awful. I don't know. I don't remember for sure if you did.
Dude, have you taken complex analysis yet?
No, that's one of the classes that I'm debating taking because
That's-
Cohen's coming back and he's teaching that.
That sounds like a cool class.
Yeah.
But I would never want to take it, 'cause it's too much.
Well, it's math. It's
I mean,
actual
if
math.
there was like a physics version of it, where there wasn't so many like proving theorems as there was like applications of theorems already proved. So I think
You
it'd
wouldn't
be
actually understand
But
it.
well, I mean,
You could wave your hands or something.
yeah,
It's not mathematical.
See, I just don't want to like write words. Like, I want to use mathematical structures and how they apply to physics. I don't really want to like use words to prove things that have already been proven.
Yeah.
I'm fine with like pure variable proofs, but as soon as I have to bring words into it, I cut it off right there.
Oh.
And you know how to get to manage file systems on Windows? How do I CD into a desktop directory?
From Sigwin?
New Windows?
Say,
From Sigwin?
well, I'm on like command line MATLAB, and I don't know where I am, but I want to like start from the top directory and go to desktop. I don't know the path.
I
Sure.
think you'd just be C://
C, capital
capital
C,
C, yeah.
colon //.
Or maybe it's just a 1/. I don't know, I just pulled up a bunch of stuff though, so I don't know. Yeah, there you go. That looks like files. Because that's like the equivalent of root, I guess.
Windows is crazy.
Yep.
I don't know what I need to use. It's gotta be a block. Or I'll just close it. I'm so. Where do they actually make? You have to write the abstract. You have to write a lab report tomorrow. That's too hard. That takes me like 10 hours.
That's why I took Chem 122 and 120.
It makes me sad. I mean, that I can say I would Chem 429.
Yeah, I strictly took like 121, 122 because I didn't want to write long ass lab reports. That was like literally the deciding factor. That was it.
I mean, that's. You probably could have taken 151 and then just taken 121. the theory and then the lab.
It's kind of nice to have a self class though.
Oh, I agree.
Lightens the load a little bit when you're.
But then I had to explain to you, this would do hybridization. Why? Unfortunately, not a name.
It's true.
Look, I did a real shitty job explaining it, so don't take anything I said to be true. Steam.
So right now it seems to work without errors, but it shows nothing because the range of energies that we show here and value, well, range of probabilities and energies are on different scales. So we need to design something creative, like either divide energy by a factor or multiply probability by a factor, or the same, without losing of the meaning.
Can you just, in the y-axis definition of that plot, can you just have it find the value of the probability at the center of the wave packet and dynamically change it so it's always at the top?
Yes. I don't know if it will be most elegant. Now it makes sense that the larger portion is reflected and smaller one did not. And it also, maybe because of the chosen size of grid points, the error accumulation is so big that the energies computed by different methods are offset by like 20%, and they are in the different regimes of operation in comparison to the heights of the.
So, is there a way that we could quantify the error between the two methods? Like, where does the error difference come from, specifically? So, I guess my question is more like, if I was to choose an application, like,
let me tell you, you were not very smart, but helpful.
Free space.
So very general. If you make the density of points much, if you make points more denser, like instead of 200 you do 500, and to explore the same region we may set up dx smaller, then anticipate that the error should decrease. See? But if we make more fine grid points along time, it also will decrease energy. So there is nothing smart. Just make it finer and finer, and you will get preciser and preciser.
So I guess new question is, Since there will always be error, is there a method that is more correct than the other for a finite size grid points? So if I was to do something serious application, which one would I choose? Or would it depend on the situation?
I do not have an answer. You may select it as one of your independent research, but remember Andrew Olson was presenting commutation, which fails completely with method 2 and gives something reasonable with method 3. So to some extent it is more trustable. And if you take the small enough grid points, they should coincide. You see, we have much better agreement between methods. By now, it's still not a commercial product. It will never be, but we can improve it a little bit so that we enjoy it more during time of research projects and presentations. The thing that we did by collective brainstorming, the command for access tight, it makes the upper limit based on the maximal value, and then we do not see the structure. Maybe we need to either artificially add a point above, or get to this. Okay. So instead of access tight, we can explicitly set up the for x according to the size of the cell, and for y we can maybe lower h will be minimal potential, and with time we can make it negative, so we also need to look deeper. And for maximum, you can select whatever is combined. I don't know if MATLAB will agree to digest such syntaxes, but you may try to convince it. But if we tell that it was a vector, okay. And then we will just a little above, just in case.
you never added it to the axis definition.
Hmm?
You didn't add the MXMX to the actual axis definition. You put it into the definition of MXMX. You never told like the graph how high to go, basically.
Oh, it is. Okay. I still see some shortcomings, but maybe it will be enough for today to share it and go forward from here. Maybe if we are going to share it with the rest of the class, we may select some more reasonable parameters.
Is it
Hey.
fine if I work on a computer, or is there a class?
Please be our guest. Exam will be in 3 weeks. Sign up. So we may quickly test if it will work for negative. What is AAB? Mm-hmm. And I think we did set up the conditions that it will be above the barrier here. So the potential is
It seems weird that the functions are higher than the potential there.
Right.
I also see several weird things. It's boring to continue. Probably with time we should go to the what? I'm kind of panicking and trying different values without thinking, which you shouldn't take an example from me.
So did the functions get offset by like twice the ground state of energy? Because it looks like that's about where they're sitting.
This is very strange. I don't know why. Maybe let's scroll through the definitions. Maybe there is just factor 2 at the point where we multiply where v0 times barrier. Oh, here. I think this 0.5 factor plays a role.
Yeah.
So if you put it 1, it will be much more natural. Well, more intuitive to understand what is going on.
So yeah, definitely. Did it?
So now we have them 5 times different. Also there is one problem with the visualization. The probability absolute value will depend on size of the box, right? And visual, okay. Trivial result. Visual representation will be better or worse depending on the size of the box. Right now it was almost invisible. Would it be very wrong if for visualization purposes we just multiply probability by like factor, whatever, 10? Or we may design some
Well, that would offset it again.
no offset plus scaled probability. The 0 point will depend only on energy, and the scale,
Yeah.
the position of this lines will not change, but the deviation from this straight line will be bigger.
Or should you even offset it at all, or should you just straight multiply it by the energy, like you're doing with?
No, energy is added. So we do not multiply energy by anything. Same energy.
Yeah, but wouldn't that, like, if you were to take that one instead of saying 10 times prob 3 plus E3, if you just did E3 times prob 3, then at the peak of it, wouldn't that be, I feel like that would be a visualization that we'd be going for. Because it would just, I don't know, it'd scale it up, I think, appropriately.
I see what you mean.
Maybe, I don't know.
I do not.
Let's try this.
Yeah, because then you have a vertical
Yeah.
visualization of the.
Because then, like, your 0 would still be at 0, but then it should make the hump go up to that high still,
Yeah.
basically.
It would be parallel with the line.
Yeah.
Because the probability is at 1.
Right, yeah, at the peak there, then it'd be at, like, your maximum value that you're looking at, or where your energy
Well-
is.
Now,
The peak isn't necessarily at a value of 1, right?
It's usually going to be close to
so
it,
there
though.
are repeat patterns even in the
Actually, it should be
fringes.
Gaussian.
Okay. We can make one more test to see what will happen if we set it. If we set the potential negative. So we violate conservation of energy a little bit. It looks like energy is drifting.
Yeah. It might have just rescaled the graph, I guess, because your bumps got like bigger.
Yeah. And I think factor 10 is insufficient. We may like 50
What-
have it really pronounced.
What if we? I think that if we did just multiply the probability times the energy, I think that would kind of give us the visualization that we're going for here.
Then we need to also multiply the potential by the same factor.
Well, the potential is already in terms of energy, right? So they should be like
No,
comparable to
but
each other at that point.
they are separate lines. If you multiply probability plus energy by a factor and do not multiply potential, it will create confuse. It is important to see how far the total energy of the wave packet
Yeah.
deals with potential. Is it above or below?
Yeah, but
So-
I mean the way that we're defining the potential is in terms of the ground state energy anyway.
Before loop starts, and the plotting it happens inside the loop.
Yeah.
So we need to redefine not the potential, but the variable which is plotted as a potential.
What's the variable that's plotted as a potential?
Well, it is potential itself. They coincide right now, but
I think it'll work.
The potential isn't time dependent though.
Right.
right now our potential is not time dependent. Although there are no problems to do it. I have a very clear idea. I will share it in a minute. You do what you plan and show how it looks. Okay, so this is a little more visual. Good question for analysis. Why does energy fluctuate? Right now, I do not have the answer.
I don't think the energy is actually changing. I think it's just the rescaling of the graph making it look like it is.
We can set up a trajectory for energy and see
Yeah.
what comes out. And here we're plotting only real part. The formal variable can get complex, which shouldn't happen because there's a Hamiltonian is Hermitian, but so how do I call it? Dated for visual. Okay. Please try. We will discuss, and I think it will be. We will not go to any new subjects. Just be sure that we feel comfortable with this. Okay? So,
What line is this all taking place?
Hmm?
What line is this plotting to?
careful
I'm
with
not really
that.
sure what it is.
You're not wrong.
This fall, I'm trying to fool the system of National Science Foundation. The recorded success ratio is 15%. So if they give pass, no pass based on random number generator, it means that you need to submit 7 attempts to have one to go through.
What line was it that you offset your energy for the ground, or your wave packet?
118, 119.
Oh, just because there's that thing here.
The resolution is still not strong enough to see what you're typing. So this cannot count as a spying system.
What's the potential negative? Potential is not negative.
What? Oh, V naught's not. Yeah, no. When he actually does V, that's when he puts the negative sign in. V naught's like the initial potential.
Yeah,
So you gotta find V. Just control F. Yeah, there you go. Yeah, negative V naught.
what is the barrier negative? Okay, question.
Yes.
So if I do this, my barrier is negative. Where is it defined to be negative?
Here. With this minus.
Oh. I looked right at it and didn't even see it.
Right.
Okay, yeah, my bad. Okay. Yeah.
So what were we doing and what have we done? We invested in the comfort of the future. We did two things that will make individual research projects a little easier. So we did set up a new observable which corresponds to reaction yield or transmission probability and reflection probability as function of time. And second, just for better easier visualization, we did offset the probability distribution but by energy of the wave packet. I think it is enough, right? So if you have some questions, please feel free to ask, and you feel free to stay and play more, but I do not plan to offer more novelties for the day. Formal part of the meeting is over.